All right, so if you didn't submit your attendance or open up your digital notebook, make sure you do so. We are going to start on a new chapter today. And this chapter is called Crash because we are going to start learning about collisions. All right, so we had learned about forces and velocity and mass and how those all kind of intermixed. And now we had picked the second claim, talking about the pod crashing into the space station. And so this is where we're going to go a little bit more in depth with that. All right, so we're on lesson 3.1. Now, today we're going to analyze data to explain how equal and opposite forces in a collision affect velocity change. And so by the end, you're going to evaluate evidence on how forces are exerted on objects in a collision. So for activity 1, we're going to do our warm-up. We're going to read the new message from Dr. Gonzalez and answer the question. So there's going to be a question in Amplify. And then we're going to review some vocab. All right, we got a new vocab word. All right, so if you want to go ahead and press on the screen, I'm going to go through some slides real quick to talk about this new information we have from Dr. Gonzalez. All right, so if you're in Pear Deck, you can click on this screen and it'll take you to our warm-up. All right, so before you read this, we need to make sure that we're all on the same page. Like I said just a few seconds ago, we are supporting Claim 2. So we looked over Claim 1 and Claim 2 on chapters 1 and 2 the last several weeks, and now we are sticking with Claim 2. All right, so the more massive than usual the pod is, means it only slowed down. So we know that this pod is more massive than it normally is, and so it didn't stop and it hit the space station. All right, so we are going to investigate what happened as a result of the crash. Okay, so let's review this message from Dr. Gonzalez, and I'm going to read it. If you guys have already started reading it, then that's okay, but I'm going to read it. All right, so it says, so thanks to you, we understand that even though the thruster force is the same strength on all pods, this pod was affected differently because it is more massive. The thrusters could only slow this pod, and since it didn't stop, it hit the space station. Our team is thinking about a rescue mission, but we also learned that the crash made the space station move. We know the collision caused the pod to move in the opposite direction, but is the pod faster, the same speed, or slower than the space station? How far away from the space station is the pod? And how fast is the pod moving? Is a rescue mission possible? Once again, we need your help with our questions. All right, so they've got a lot of questions right down there. All right, so what you are going to do right now, after we read that, is there is a question on Amplify that you're going to answer. So I'm going to go back to that screen. If you want to press on this screen again, it'll take you to that warm-up. So go ahead and answer that one question and Amplify and press hand in. When you are done, make sure you come back to our Pear Deck. I'll give you guys about 2 minutes to answer that question. All right, so once you get done with that, once you click hand in, let's go ahead and share some of our ideas about collision. All right, so in that warm-up, the question that it was asking you was, if two objects crash into each other, what happens? Are both objects affected? How? And if you can, give an example to support your ideas. All right, so if two objects crash into each other, what happens? Y'all can either unmute yourself or type it in the chat. All right, we're just kind of sharing our ideas and our answers to that warm-up question. All right, so if you guys are done, we should be sharing our ideas. If you have answered that warm-up question, let me know how you guys answered that. You can either put it in the chat or unmute yourself. Nothing? We don't have any ideas? All right, Korean sent me a message. So both of them are going to be affected, because if they are two different size objects and they both hit the one that is small, it will slow down, stop moving, or change the way it's going, and the big object will slow down. All right, we got another one. If two objects crash into each other, collision occurs. This may cause one object to slow down or speed up. So an example is a car crash. So that's where we get a lot of good examples, is when we're talking about car crashes. Anybody else? What happens during a collision? Are they both affected, and how? All right, nobody else, just two people? Nobody knows what happens when two objects crash into each other? All right. Well, we have a vocab word, and somebody brought it up, and it is collision. So this is going to go in lesson 3.1, where it says important ideas. Actually, sorry, this is going to go in that first, on the first page of chapter 3. My bad. Where it has all of the vocab words for chapter 3. Okay, so go ahead, open up your digital notebook, and we're going to put this word in. So collision. So I'm sure you guys have heard this word before, but we're going to give it a definition. So collision is the moment when two objects hit each other. All right, so go ahead, make sure you have your digital notebook up. Put this vocab word into where it says chapter 3. And I will let you know what page it is on. I'm pulling it up right now. All right, so this is the only vocab word for chapter 3. All right, this is the only vocab word for chapter 3. We are going over collisions and crashes for chapter 3. So that is why that is the only vocab word. So it is on page 13 if you are still trying to look for it. So page 13 if you are still trying to look for where the vocab word is. All right, if you go down to that next page, so page 14, that is what we're going to be on next. We're going to read an article here in a minute. So if you want to keep it on page 14 after you type in the definition for collision, then you can stay on that page, and that's what we will come back to when we read this article here in a second. All right, so we got collision. Now, Dr. Gonzalez wants us to help the team determine how the pod is moving as a result of the collision with the space station. All right, so now we're going to look at 3 brand new claims that talk about this collision between the pod and this docking space station. All right, now here's our question. After the collision, how does the pod's motion compare to the motion of the space station? All right, so we're comparing the motion of the pod that's carrying our asteroids and then the motion of the space station, the place where the pod is docking. All right, now we've got claim 1, claim 2, and claim 3. All right, claim 1 says the pod is moving faster than the space station. Claim 2 says the pod and the space station are moving at the same speed. And claim 3 says the pod is moving more slowly than the space station. Jaden, the page is 13 to type in the definition for collision. All right, so we've got these 3 claims. All right, so they are right here. We're going to share some of our initial thoughts about which claim best explains the motion of the pod after the collision. All right, go ahead. I want to see what your all's initial thoughts are. So after the collision, how does the pod's motion compare to the motion of the space station? All right, you're going to pick which claim you think is correct and why. All right, so is the pod moving faster than the space station? Is the pod and the space station moving at the same speed? Or is the pod moving more slowly than the space station after they collide? All right, so we know that they crashed into each other and the pod is moving away from the space station. But we need to know how fast the pod and the space station are moving. All right, so if you have not already started typing your answers out, make sure that you are responding in Pear Deck. All right, make sure you're responding in Pear Deck. It looks like I got about half of us, a little over half of us responding. What are some of your all's initial ideas or thoughts about which claim best explains the motion of the pod after the collision? Right, so claim 3, because if after something hits another object, it would have to go slower. Claim 1, because it would have to move faster to hit the space station to go in the other direction. Somebody just says the pod's going to move more, or I guess you mean faster than the space station? Maybe it's moving at the same speed. All right, so this one is correct, but what's happening after the pod hits the space station? So the space station, it's just floating there. It's kind of just still. And so this pod is moving, is the one that's moving since it's planning to dock. But what's going to happen after the pod hits that space station? All right, so we're kind of all over the place. Kinsey, yes, the pod bounced off of the space station. All right, so I just wanted to see where we were at right now. Later on in this chapter, we will eventually support one of these claims. All right, so that is what I just said. At the end of this chapter, you're going to write a report for Dr. Gonzalez. And so you will give a complete explanation of the pod's collision with the space station, as well as details about the speed of the pod compared to the space station. All right, now what we're gonna do a reading. So I told you guys to be on page 14 of your digital notebook, and that's because there's gonna be some questions in that digital notebook. All right, so what we are gonna do, I'm gonna give you guys time to read and annotate the article. It's called Crash, Forces and Collision. And so I need you to have at least 3 annotations. What we're gonna do after our reading, and after you answer the 2 questions that are in your digital notebook, is we are going to discuss, and we're going to discuss those annotations. So that is why I want you to have at least 3 of those. All right? I would like for you to pick at least one of those that you could share or talk about, or maybe you have questions about it. Okay, so we're going to read and annotate the article, and you are going to have 3 annotations. 3 annotations. Okay, so before we get started, we need to look at our investigation question. So this is what we're going to investigate today. So what are the forces like in a collision? What are the forces like in a collision? All right, so Dr. Gonzalez sent an article about collisions that happen in everyday life here on Earth. And so this may help us learn what forces are like when objects collide in space. All right, remember our active reading skills. You guys are going to annotate to show your thinking. Some strategies you can use, such as you can use asking questions and returning to a question. And then our focus strategy for this unit is asking deeper questions. Okay, so we're going to ask a little bit deeper questions in order to understand what is going on with this crash. All right, so go ahead. You can press on this screen. I'm going to give you guys probably about 10 minutes to read this article, annotate this article, and then the questions that you have on slide 14 in your notebook, in your digital notebook. Okay, you've got 2 questions there talking about collision, and then you are going to read and annotate your article. All right, so 10 minutes, we'll come back at 10:40. If you get done before that, then just sit tight. We are going to talk about our annotations. So if you want to make sure that you have an annotation ready to share, then that will be perfect. That'll get us moving along. All right, 10:40, we're going to come back. Make sure that you read this article, have 3 annotations, and then answer the 2 questions in your digital notebook. All right, so make sure that you have at least one of those annotations pulled up right now. All right, you should have also answered those questions in your notebook. We are not doing anything else in our digital notebook, so if you want to go ahead and close that, you can. If you need to come back to those questions, if you haven't finished those questions, then you can keep that open. But if you have finished, you can go ahead and close that. All right, we're going to look over our annotations and choose some to discuss. So I'm hoping that you guys have already picked out the one that you would like to go over. All right, so if we were in class, we would have done the share, discussed, and present hashtags. All right, we would have shared it with a partner and discussed it with a partner, and then we would have presented it to the whole class, or at least a few. All right, so look over those annotations. Make sure you choose one that we can discuss. All right, and this is where we're going to put them. This is where we're going to put some of those annotations or any questions that you have about the article. All right, so they don't have to be a question. They can just be an annotation that you thought was really important. All right, so go ahead, put that in this slide on our Pear Deck. All right, so any interesting facts or unanswered questions that you still have about the article. All right, so make sure you're responding in Pear Deck. Looks like I got a little less than half of you guys responding. So make sure you finished up that article. I gave you guys about 10 minutes. And you're going to put any interesting annotations or any unanswered questions that you still have about the article in here. All right, and I'm going to look at them and we'll talk about them. All right, so those 8 of you that have not responded in this, you need to make sure that you're responding. All right, so the world is full of things running into each other. All right, so the cue ball comes to a complete stop after the collision. So talking about pool, if you guys have ever played pool, the white cue ball comes to a complete stop after hitting the other ball. Not so sure if it comes to an actual complete stop as soon as it hits them. I guess it kind of depends on the type of collision, because sometimes that white ball will still keep going after it hits one of the other color ones. Objects with less mass go quicker and don't need a lot of force to move it compared to objects with more mass. When collision occurs, the object with more mass moves slower than the object with less mass. Things with the same mass result in an equal force. All right, that's a good example right here. Talking about bumper cars. So the article explained how different masses can cause an equal amount of force. So the difference in the masses is what makes the objects react differently, and even though the masses are different, both objects will have an equal force change. What do we use to measure the velocity of both of the items, and how can we exactly tell how much they're changing? That's a good question. Hopefully we can figure that out when it comes to the pod. All right, so these are really good. All right, so the last thing that you guys have to do is the homework. So it is activity 4. You're going to open up the Force and Motion sim and select the 3.1 homework from the drop-down menu in the top left corner. And so you're going to run multiple simulations creating collisions. All right, these setup examples are on the next slide, and they are also on Amplify. Okay, you've got a few questions to answer after that. So there are, it looks like 5 different collisions that you need to set up in your homework. Okay, so your first collision is going to be where an object runs into another object that is not moving. So one object is going to be moving, the other object is going to be sitting still. Then you're going to have a collision where an object runs into another object that is moving in the opposite direction. So that means you're going to have 2 objects moving at the opposite direction. So one's going to go to the left, one's going to go to the right. Then you're going to have a collision where an object runs into another object that is moving in the same direction. So maybe you have one object here, one object here. They're both going this way, but the one in the front is going slower so that the one behind it can bump into it. All right, the last 2, you're going to have a collision between 2 objects that have the same mass. Okay, a collision between 2 objects that have the same mass. And then you're going to do that same collision, but with 2 objects that have different masses. And so I would suggest having 2 objects that have the same mass going at each other, and then doing that same kind of setup, but just with 2 objects that have different masses. And they run into each other. Then you're going to look at the difference of the collision and how different they are because of the masses. All right, so you are going to explore collision forces in this sim. So if you want to go ahead, we've got plenty of time to work on this right now. You can press on this screen and it's going to take you to tab 4 in Amplify, which is our homework. All right, so if you want to look at my screen, I'm going to show you exactly where to go in this simulation. The 5 collisions that you have to set up are right here that I just went over. They're in Amplify, right? The question that you have to answer is right here below that, but you need to open up the Force and Motion simulation. And then it said in the top left corner is where you are going to click on the 3.1 homework. So you've got these 3 lines up here. You're going to scroll down a little bit. It's one of the last ones. It's going to be the 3.1 homework. Okay, so go ahead, press on that. And it's going to tell you to set up collisions between objects and observe the forces and changes in velocity. So it doesn't have any objects here. What you're going to do is you will move these objects into this space. And so you can choose whatever objects you want. You can make them go away. You can just rebuild if you don't want any of those. All right, but you're going to set up those collisions, those 5 different collisions, and then observe the forces and changes in velocity. So when I say observe the forces and changes in velocity, you'll need to set something up. So I'm just going to set up a collision here real quick. go to run. We've been doing this, so I'm hoping you guys know exactly how to set up these collisions. I'm going to just set up a collision. And then when you go to analyze, that is where you will see the change in velocity. And then you will see the force as well. When you do this blue scrubber bar back and forth down here at the bottom, you'll see the forces. Okay? All right, there is no table that you need to fill out, but there is a question. So make sure that you do those 5 different collisions and then answer that question at the bottom. Okay? All right, after you get done with that, I'm going to let you guys have time to do that. After you get done with that, you're going to do the exit slip for lesson 3.1 on Canvas. Okay, so these are the last 2 things that you need to do. If you can get them done here in the next 15 minutes, because that's how much time we have left of this class, then that's perfect and you won't have to do anything after class. Okay, so we're going to work on the homework right now. And then you guys have the exit slip for lesson 3.1 on Canvas. All right, so let's stay on for a little bit. Make sure you get that homework done. And if you have any questions, let me know.